This is section 5.2, day 1, and we are not going to be taking notes today, but you will need your graphing calculator, so you can get that out at this time. And what we're going to do is we're going to put a program onto our calculator. So at your desk you should have a school issued calculator, and you should have a cable. And what I want you to do is I want you to attach the cable to the school calculator and to your calculator. Now on your calculator is going to be receiving the program, so this is your calculator. So on your calculator, what you want to do is you want to press second link. So you want to go second link, link is the variable key, and then after you press second link, you're going to get this screen and you're going to arrow over to receive. And you're going to select option 1 to receive a program. And when you select option 1, your screen is going to flash up with this message that says waiting, and it's going to have this little worm here that's waiting. It's processing your commands. Okay, so that's your calculator, and your calculator can just sit there and wait. And while that's just sitting there, now you're going to go to the school calculator. So you're going to grab the school calculator. The school calculator is going to send a program. And so on the school calculator, you're going to press second link. So the same keystrokes, second link. And then when you press second link, you're going to get this screen, and you're going to stay on the send. And you're going to pick option 3. Option 3 is sending a program. And so when you select option 3, you're going to get a list of programs. It might not look exactly like this list, but it'll have a list of programs. And somewhere in that list, when you arrow down, you're going to see the word Riemann. So you're going to keep arrowing down until you see the word Riemann. And then once you see this word Riemann, you're going to hit enter on your calculator. So that enter is that, that lower right-hand button. And when you hit enter, what you'll notice, it's hard to see here, but this arrow, this triangle, will turn into a little box. And the way you can see that better is after you hit enter, when you're on Riemann, if you arrow up a little bit, you'll see that there's a little box next to Riemann. We need to have that box there. It doesn't matter where this is, but that box needs to be next to Riemann. That means you've selected this program, and we're going to send it. So now you're going to arrow to the right so that you're on transmit. And then you can pick option 1 here. So you're transmitting the program from the school calculator to your calculator. And when you hit transmit, it'll pop up on the school calculator Riemann program, and the worm will work for just a second or two. And when it's done working, if there's no errors encountered, it will say done. And once you see done on both screens, okay, once you see done on both your screen and the school screen, then the program's been installed. Okay, so this is what we're going to use the program for. A Riemann sum is basically a sum of values. So notice we're taking a value and adding another value and adding another value, and this is the notation for it. So basically it says I want to start at a value of 1 and go up to some value n, and I'm going to plug those values into some function, and then I'm going to add them together. So for instance, if the function's x squared, x squared, that's a parabola, and we're going to plug in 1, and then we're going to plug in 2, and then we're going to plug in 3, and then we're going to plug in 4, and then we're going to plug in 5 and stop. And each time we plug it in, we're going to square it. And then we're going to take all those values and add it together. So the sum looks like this. When I plug in 1, I square it, I get 1. When I plug in 2, I square it, and I get 4. When I plug in 3, I square it, and I get 9. When I plug in 4, I square it, and get 16. And when I plug in my final value, 5, I square it, and I get 25. So a Riemann sum is adding up all of those sums that follow this pattern of squaring the input. And so when I add this up, I get 55. So that's all fine and good. That's just an algebraic process of summing up numbers that follow a pattern. In this case, the pattern that they follow is x squared. They're following the points on a parabola, basically. So if we look at that from a graphical standpoint, we can put in values 1 through 5 into our function, x squared. And so when we put in 1 into x squared, we get 1. There it is. And when we put in 2 into x squared, we get 4. When we put in 3 to x squared, we get 9. When we put in 4 to x squared, we get 16. And when we put in 5 to x squared, we get 25. So the 1, 4, 9, 16, and 25 are the y coordinates, the y values, the function values. And so if we think about this then, this Riemann sum, this sum of values, and it's kind of random, but they do follow pattern. The pattern's x squared. We can incorporate this and apply it to our approximations. So in other words, we're going to use these points and we're going to create rectangles in this space. So the first rectangle looks like this, the second, the third, the fourth, and the fifth. So if you notice, the values 1, 4, 9, 16, and 25, they happen to be the height of the rectangles we would use for an approximation. And what is this approximation? If I'm using the heights here on the upper right-hand corners of each rectangle, this approximation is going to be an R-RAM, or a right Riemann sum, a right rectangular approximation. And so each one of these then has height of 1, 4, 9, 16, and 25. In other words, each one has height of x squared, or the function value, and it has a width of 1. So this area here is 1, this area is 4, this area is 9, this area is 16, and this area is 25. And so what happens then is this Riemann sum happens to be a right rectangular approximation. So that's why we call rectangular approximation Riemann sums, is because they follow this summation pattern. So let's do this Riemann sum now on a calculator. So we're going to use that program. And so we're going to hit second and program. Excuse me, we're just going to hit program. We're not going to hit second. My apologies. We're going to hit program here. We're going to use the program button. And when we hit the program button, it'll show us all the programs in the calculator, and we'll find the one that says Riemann, and we'll select that. And then it's ready to run the program. It says program Riemann. So we'll just hit enter, and it's going to ask us for our settings. So our function is x squared, and then so we type in x squared and we hit enter, and then we have to set up these settings, and it's going to ask you one at a time. So notice this is what's different about an approximation, and it's different than just using the algebraic expression. We're plugging in values from 1 to 5, right? We start at 1 and we end at 5. But since those are the right corners of the rectangle, our approximation really encompasses the region from 0 all the way out to 5. So our lower bound is 0, and then our upper bound is 5. And we want to make the partitions are the sub intervals, so we want to make 5 rectangles. So we have 5 partitions. and then you press enter, and it shows you the quadratic, the parabola. And this is ending at 5. The tick marks are kind of irrelevant, but we're going from 0 to 5. And then it allows you to do all of the sums. So this is a right Riemann sum. This is an R-RAM, a right rectangular approximation. Those terms are used synonymously. And so we're going to pick option 3, a right sum. And it's going to draw it for you. And it's going to give you the value. Right sum is 55. So the rectangular approximation, the R-RAM, is 55, and that follows a Riemann sum algebraic pattern. And so we can see that the Riemann sum and the rectangular approximation are one and the same, which is why we use the terms interchangeably. So we also mentioned that we could find the definite integral. In other words, we could find the actual area of this region, even though it's not geometric. And that actual area of that region is 41 2/3. And right now we're gonna section 5.2 is gonna focus on using the calculator to find this value. That's what tomorrow's lesson will be about. So just to get a little proficiency with using the Riemann program, we're going to go back to our function that we've been working with in section 5.1 and 5.5. And you're going to go ahead and do a left sum, a right sum, a midpoint, and a trapezoidal. So remember the LRAM, RRAM, MRAM, those were from section 5.1. And the TRAPRAM was from section 5.5. So remember your LRAM is 5 3/4. Your RRAM is 7 3/4. Your MRAM is 6 5/8. And your TRAPRAM was 6 3/4. And then the definite integral I told you when we were discussing section 5.5 was 6 2/3. So go ahead and put into the settings, go ahead and put your function in, which is 1/8 t squared, or in this case 1/8 x squared plus 1. And go ahead and do each one of these options 2 through 6, and make sure that you are able to get those values so that you know you're using the Riemann program correctly. And then to get you started on using that Riemann program, here is, I'm just going to go through the steps for the LRAM. So I'm going to hit Program, and then I'm going to arrow down to Riemann. It's going to be somewhere in your list. It might not be the same option number as mine. I'm going to hit Enter. So Program Riemann, I'm ready to start the program. So I hit Enter again. My settings, my function is going to be 1 divided by 8 times x squared. So times x squared. Oops, that's not a squared. Squared. There we go. And then plus 1. So the syntax, since we have a divide and a multiply, this syntax is okay without brackets. And so I'm going to hit Enter. And I'm going to have a lower bound of 0. And I'm going to have an upper bound of, I believe I went to 4. And I'm going to have 4 partitions, in other words, 4 rectangles. So here's my function from 0 to 4. Now I'm going to go ahead and do my left approximation. So I'm going to arrow down to option 2, left sum. And there's my left sum of 5.75. So now I can hit Enter again, and I can pick a different one. Now I can go hit my right sum and my midpoint, my trapezoidal, and my definite integral, and I should get all of those answers that that you were shown in the PowerPoint presentation. And then you can go ahead and finish your sections 5.1 and 5.5.